Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to explain exception handling in Python, so sit back, relax, and enjoy the show. If you wouldn't mind, please like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Well everyone, let's talk about exceptions. An exception is an event detected during execution that interrupts the normal flow of a program. Here's a program that I've written, and we're intentionally going to cause an exception. So this program that I've written, we will accept a numerator and a denominator from the user. We'll divide the numerator by the denominator, we'll get a result, and print the result. So what if I were to divide a number such as 5 divided by 0, which we cannot mathematically do? Well, this will cause an exception, an event detected during execution that interrupts the flow of a program. So our program was interrupted, and within our console window, we have this traceback message, which states what went wrong and a name for this exception that occurred. This specific exception that occurred is a zero division error. So this video is all about handling these exceptions so they do not interrupt the normal flow of a program. Now, a very basic form of exception handling is to surround any code that is considered dangerous, as in it might cause an exception within a try block. Anytime you accept user input would be a good indicator too. So this code is considered dangerous because we don't know what the user is going to type in. So we will try all of this code. If an exception occurs, we can catch it and handle it. So to do that, we'll add an except block, except, and then we will catch exception. Normally, having this block by itself isn't considered good practice, but I'll explain why later. So this except exception block will catch all sorts of different exceptions, and it will prevent our program from being interrupted. And we can do something else entirely, such as print a message. Something went wrong. So let's try this again. We will divide 5 by 0, which we cannot do. We no longer have that traceback message within our console window. We caught the exception, and we did something else. We printed something went wrong. Like I said before, it's not considered good practice to have a single except block that will handle all exceptions. It's much better to first handle specific exceptions when they occur, and we can do so by writing additional except blocks. So let's create an additional except block that will catch any zero division error exceptions. That occurs when somebody attempts to divide by 0. So if this exception occurs, how do we want to handle it? Let's just print a message. Let's print you can't divide by 0, idiot. And let's try this again. So 5 divided by 0, you can't divide by 0, idiot. Here's another one. I'm going to turn this except block into a comment so we can take a look at something. What if I divide by something that's not a number? Like we take 5 and divide it by the word pizza. Well, pizza's not a number, and we ran into a value error exception. So we should probably handle this too. So let's create another except block that will handle that. Except value error. And how do we want to handle this? Let's print something. Enter only numbers, please. Okay, let's try this again and see if this exception is caught. 5 divided by the word pizza. Enter only numbers, please. Not only that, but you can also add the exception block at the very end, just in case there's something you won't anticipate. But it's always considered good practice to first catch any specific exceptions and let the user know exactly what went wrong. An additional way in which we can handle these exceptions is that we could display the exception that occurs, although it is completely optional. So to do that, what we'll do is that after each of these except block definitions, let's add as e. So we're calling the exception as e. That's just standard practice, although it's not necessary. So let's do that for each of these except blocks. And then we can print whatever e is. So let's add that to each of these blocks. So it should now look something like this. So when we encounter an exception, we can display what exception occurred to as well. So let's divide 5 by pizza. Invalid literal for int with base 10. Pizza. Enter only numbers, please. So like I said, this is an additional way in which you could handle an exception, although it's entirely optional. Another thing that you can do is that you can add an else statement to the end of your except blocks. So what's happening here is that we're going to try all of this code. If an exception happens, then catch it and handle it. If not, then do something else. So why don't we print our result only if there are no exceptions that occur? So if there are no exceptions, we will execute this else statement. If not, then we won't. So let's divide 5 by an actual number this time, like 2. So there are no exceptions that occurred, so we executed this else statement, whatever code is within our else block, and this printed the result of 2.5. But if an exception were to occur, like we divide 5 by 0, then we will catch our exception and handle it, and we do not execute whatever block of code is within our else statement. There is one other clause that you should be aware of. That is the finally clause. This is always at the end. How this works is that whether or not we catch an exception, we will always execute any code that is within the block of code for our finally clause. So this is a good opportunity if you open files to close them within the finally block, but we haven't dealt with opening files yet, so we won't do that. All we'll do is just print something. Print, this will always execute. So whether or not we encounter an exception, this finally block will always execute at the end. So let's try this again. So this time, let's cause an exception. Let's divide 5 by 0. You can't divide by 0. This will always execute. And this time, let's take this seriously and divide 5 by another number, such as 3. So this will give us a result. And like I said, the finally clause, the code within the finally clause, will always execute. But we won't really be working with this until we get to the section on file handling. Well, everybody, those are exceptions in Python. They are events detected during execution that interrupt the flow of a program. And we can handle these exceptions by using try and except blocks. So if you would like a copy of all this code, I will post all of this in the comments down below. But yeah, that is how exceptions work in Python.
Hey you. Yeah, I'm talking to you. If you learned something new, then help me help you in 3 easy steps by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro.